Cockpit instrumentation has come a long way since the Wright brothers simply looked out the front of their flying machine. No longer are pieces of string or vacuum-driven gyros used to determine flight conditions. These days, electronics have replaced many of the earlier instruments, and cathode ray tubes are used to display the information. The PC-9 you fly has the latest and most modern flight instrumentation of any trainer in the world. In this session, we will look at the electronic flight instrumentation system, or EFIS, fitted to the PC-9, how it works, what can go wrong, and how it is used. Firstly, you see the equipment fitted to the PC-9. Differences between the front and rear seats? Very little, really. The instrumentation is exactly the same. In fact, the displayed information is also the same. All of the controls operate in tandem, so whenever a selection is made in one cockpit, it appears on both sets of the instruments. The only difference between front and back is the circuit breaker panels, which are mainly located in the front. The EFIS system consists of two display screens, the electronic attitude indicator, or the EADI, and the electronic horizontal situation indicator, or the EHSI. The EFIS control panel and the oblique heading select panel are located here immediately beneath the EHSI. There is also an EFIS swap button here, under COM2. In the electronics bay, there is a symbol generator which drives all four displays. If there is a problem with any display, the screens can be swapped over by pressing the EFIS swap button. However, in the unlikely case that the signal generator fails, all screens will be unusable. In this case, you would have to fly on the backup instruments. We'll talk more about systems failures later. The instruments are normally turned on when the inverter switch and avionics switches are turned on. The intensity of the display can also be adjusted. Now to look at each display and see what information is available. The EADI. This is the primary instrument for pitch and roll, and the secondary for heading. The aircraft symbol in the center of the instrument remains stationary, and the center of the dot represents your present situation. So in this case, we are wings level, with 3 degrees of pitch and a heading of 173 degrees. Notice that the sky is blue, the ground is brown, and the appropriately named sky pointer will always point vertically upwards. As far as scales go, the roll scale is calibrated in 10-degree increments. Pitch is in 5-degree increments, with a long line every 10 degrees. Heading is in 5-degree increments, marked every 30 degrees. At the bottom here is the rate of turn indicator. The scale marks indicate rate 1. The inclinometer is the only mechanical part of the instrument, and it shows slip or skid. Full scale is rate 2. The inputs for attitude, heading, and rate of turn come from the attitude heading reference system, or the AHRS. On the left-hand side of the EADI is the fast-slow indicator. It receives information from the angle of attack vane. The middle index indicates the ideal approach speed, and the fast and slow indices indicate 10 knots, fast or slow. Unlike the AOA indexer, the fast and slow does not disappear after the landing gear is retracted. On the right-hand side of the instrument is the glide slope scale and pointer. This only appears if a localizer frequency is selected and the aircraft is within 105 degrees of the selected course. The runway symbol appears whenever a localizer frequency is selected. The runway is extremely sensitive and is useful as a trend indicator on finals. Down in the bottom left-hand corner is the marker beacon symbol. It illuminates OM in blue for the outer marker, MM in orange for the middle marker, and the IM in white for the inner marker. I'll press the test button and you can see the 3 markers overlapping. The marker beacon is active whenever the marker receiver in the VHF nav receiver detects a signal. The final component on the EADI is a photocell up here. It provides a small amount of brightness compensation to the display unit. Now, any unreliable information is highlighted in red, either red words, red lines, or red crosses. For example, in this case, the glide slope is unreliable and has a set of parallel lines running through it. That's the EADI and what it displays. Now, The EHSI can be operated in a number of modes, and the displays are quite different. Mode selections are made on the EFIS control panel here. This panel also controls the brightness of the screens by using the knob on the right-hand side. It clicks off, and this turns the brightness off. It does not turn the system off. The outer knob adjusts the EADI, and the inner adjusts the EHSI. Now, the mode select buttons for the EHSI are these push-to-select buttons here. Okay, firstly HSI. The EHSI compass display can be in two formats. At the moment it is showing the full 360-degree compass rose. A push of the HSI button and it changes to 120-degree sector display. Notice the larger scale. This display is particularly useful for instrument takeoffs, GCAs, and other times when accurate heading control is required. Another push, and the display changes back to 360-degree format. The next button is the nav map button. At the moment, the system is showing the HSI compass card, or nav format. When the nav map button is pushed, it changes to a map display. As you can see, this format shows the selected TACAN station and radial in plan view. In this case, the TACAN station is ESAL, and the selected course is 060 degrees. The scale of this display can be changed with the range buttons. Push the range up to increase the scale of the map display and down to decrease the range. The range scales go from 2.5 nautical miles up to 500 nautical miles. Now, push nav map again, and the nav or normal HSI format returns. We're back to the selected radial and course deviation bar. The pointer selection switches determine which radio aids are displayed on the needles of the EHSI. The single white arrow displays either VOR or TACAN, and the selection is shown in the bottom left-hand corner of the display. The magenta double RMI pointer selects ADF or nothing, and is shown on the bottom right-hand side of the display. The nav button selects VOR, localizer, or TACAN, depending on which is tuned on the VHF nav set, to be used for the CDI and radial displays on the EHSI. In this case, the TACAN. ADF selects the tuned NDB as the displayed aid. The format the same for nav. In this case, the ESAL NDB. Now remember the differences here. The pointer selection switches control the white and magenta pointers on the EHSI, and the nav and the ADF buttons control which aid is being used for the green CDI or primary display. DG is the raw instrument mode, and no radio aid information is available at all. With DG, only the compass card and heading bug are shown, a very uncluttered display. Also, with DG, the only warning flags which will appear are the attitude and heading flags. If DG is pressed twice, the display returns to the HSI format. A special point to note here is that with the localizer, the single white RMI pointer disappears. They are the mode buttons. Now to have a closer look at the EHSI displays. So at present, the EHSI is in standard HSI format, and the ESAL TACAN and NDB are tuned. Notice the bottom left-hand corner shows the white pointer is indicating the bearing of the TACAN. The TACAN distance is shown there, and also up in the top right-hand corner, along with the ground speed. Use this ground speed cautiously because it's calculated by the rate of change of DME distance. This means that the ground speed is only valid when the aircraft is tracking directly to or from the station. Now, there is another very useful function available with distance. Say, for example, you are tracking from the ESAL TACAN to a VOR without any DME, and you need to tune the VOR for tracking. This DME hold button allows you to have the VOR as a tracking aid and the DME readout from the TACAN. So, press it and notice that the ground speed disappears and the DME frequency appears instead. I've now selected the VOR frequency for Malakuta and the ESAL DME remains. Press the button again and the system looks like a single aid. Very handy. In the bottom right-hand corner, see that the pointer 2 is showing ADF. In this case, the ESAL NDB. Remember, the pointer 1 can only display TACAN or VOR, and pointer 2 can only display an NDB. The two arrow buttons control the white and magenta pointers on the display. The aid which is used for the green CDI bar is shown on the left-hand side of the display. In this case, the TACAN is selected and a course of 060 is shown. So from this display, we can see that we're on the 265 radial at 1.3 nautical miles from the TACAN. If, say, the NDB goes off the air, then the red crosses at each end will cover the pointer to show that it is unreliable. If the TACAN now goes off the air, the indications change. Notice that the white needle disappears completely, and the red bars through the CDI tell you that the nav source for the CDI is unreliable. The green course deviation indicator is calibrated so that each dot represents 5 degrees in all modes except localizer. With localizer, the dot is a function of the ILS installation. The to from indicator indicates directions to a station in all modes except localizer when it is out of view. The black lubber line or heading symbol indicates a present heading, and the orange heading bug moves around the compass card to show selected heading, like this. The desired course and heading are set with, you guessed it, the course heading select panel. Now, there is a special time-saving function with these knobs. Rotate them normally to set a course or heading. But if you pull the course knob momentarily, the CDI will center and give you the direct course to the selected station. Similarly, a pull of the heading knob will slew the heading bug to beneath the heading symbol. So much for the standard HSI display. Remember that if the HSI button is pressed, we get a 120-degree sectored format. There, that's it. The main difference here is that you lose 3/4 of the compass card, so it's much easier to read the compass accurately. A digital heading bug readout is also shown under the heading bug. There are range markers with a half full scale distance shown on the inner circle. Now, we said before that the scale is set with the range buttons and can be anywhere between 5 and 1,000 miles. The increments for the inner scale are 0.5, 5, 10, 20, 40, 80, 120, 160, and 500. Also at the bottom of this sector display is a CDI presentation and to from indicator. The indications when nav map is pressed again to give the map display are the same with either TACAN or the VOR stations. Of course, you'll only have a distance readout with your VOR selected if there's a co-located international DME station. However, if a localizer is tuned, the presentations are quite different. We'll tune the ESAL 22 ILS and note the differences. Right, the final course is 224. So I'll just dial that in. Now, notice that there is a glide slope scale and pointer on the right-hand side. This only appears localizer selected when the dial course is within 105 degrees of the aircraft heading. Notice also that it has appeared on the EADI. The other point to notice with the localizer is that the single arrow bearing pointer is gone. Press Nav Map again to switch back to the HSI format, and the presentation changes to the full compass rows. Distance will also be blank unless the ILS has co-located DME. The only other mode to look at with the HSI button is ADF. As you can see, the presentation is the same for VOR or TACAN. There will be no DME or ground speed available with ADF, and of course the accuracy is much less. The bearing accuracy is plus or minus 3 degrees, and your tracking tolerance is plus or minus 5 degrees. With the VOR, the accuracy is plus or minus 0.5 of a degree. All right, that covers nav mode. Now for the map mode. This is really only useful for en route navigation or instrument work because it gives a map-like presentation of your flight. To set up a map display, I'll go back to the full compass and nav. So the display shows the East Sail TACAN as a navigation source, 060 as the desired course, and 1.3 as the distance. Now, push the Nav Map button, and the display changes to give a map-like presentation. Notice that at the bottom of the display is a CDI presentation as before. There is a symbol for the TACAN station, and the desired course is shown with a line. The range circle displays the scale in nautical miles. The outer circle map also works in the 120-degree format. This display is similar to the sector display from before, except that this time, the 2 from annunciator above the aircraft symbol is replaced with a 2 from near the course readout. The digital heading readout is also back. The limitation with MAP is that it's only useful for TACAN or VORTAC stations. It will not draw symbols for any other radio aids. That is the EFIS system. It's a very flexible system, but remember a couple of points when you use it. Firstly, the sectored compass display is ideal for flying headings accurately, but for general orientation, the full compass display should be used. And secondly, if a localizer is a navigation source, the white RMI pointer is not available. Thirdly, ground speed is only accurate if you are tracking directly to or from a station. And finally, the ILS glide slope presentation will only be displayed when you are within 105 degrees of the desired course. Now, what can go wrong with the system? The short answer is not very much at all. The equipment has few moving parts, and everything has a backup power. However, there are a few abnormal situations which can arise, and we'll cover them now. Firstly, as I mentioned earlier, all 4 display units are driven by a single symbol generator. If it's not your day, and it fails, you will have to fly under standby instruments. But, if a display screen fails or is unusable, simply press the EFIS swap switch here. The 2 screens swap over, and the switch illuminates to remind you. That is quite straightforward, but what if the control panel fails and you can't make any selections? In this case, the symbol generator will automatically set the EHSI picture to a standard HSI format, and a yellow CP off will be displayed in the upper left-hand corner of the EHSI. The symbol generator will also select NAV for the nav mode so that you have a VHF radio aid on the EHSI. both the RMI needles will disappear. The heading bug will slew to the lover line and then follow the compass card, and the course pointer will slew direct to the station and stay there. That all sounds a bit complex, but in fact it's easy to use if you're ever unlucky enough to lose both control panels. So how does a system know if there's been a failure? Well, it is continuously checked by built-in testing routines, and you are alerted if any problem is found. So they are the bad problems. Some of the other fault warnings and indications you've already seen. If any radio aid information is unreliable, you will see a combination of red crosses and red parallel lines like this. If you see attitude foul, heading, or SG in red, you know the information is unreliable. If anything appears in yellow, maintenance action is required and there's nothing you can do about it. And that's about all that can go wrong. And don't forget, the basic airmanship point of checking circuit breakers before pulling the handle, it could save you a lot of paperwork later. Now, to see the equipment in action, we'll fly a short sortie just to see how the system works airborne.
We're taxiing at Laverton, and the Laverton NBD and TACAN are tuned. The TACAN is selected on the EHSI, and a course of 260 is dialed up with the expanded heading scale. When safely airborne and after takeoff checks are complete, press HSI to select the 360-degree compass. The intercept heading for 260 is 305, so dial that in and start the turn. 30 degrees of bank for an instrument turn, and the green speed indicator remains after the gear is up. Notice here that we are tracking away from the TACAN, which is the white needle, and that we are passing a beam, the NDB, which is the double needle. Pull the heading knob to slew the heading bug to the present heading. Notice the ground speed is in the top right-hand corner. It's only valid when you're tracking directly to or from the station. Now for the level off. Now for the level off. Right. Time to take a closer look at the various functions. Firstly, nav map for the map display. 3 things here. Firstly, the TACAN symbol and the course line. Secondly, the CDI presentation at the bottom of the screen. And thirdly, the from indication is in the top left-hand side of the screen. Press the range knobs to vary the scale, like this, and notice the aid symbol disappears with the 2.5 mile scale. Also notice the ground speed, because we are now abeam the station. Now for a right turn. During the turn, select the Melbourne VOR and pull the course knob. We're on the 032 radial from Melbourne. The VOR has co-located the DME station so the ground speed works. Now reselect TACAN and press the DME hold button. We are still tracking to the Melbourne VOR, but the distance is now from the Laverton TACAN, and the ground speed disappears. Now to display the NDB. Also press the ADF button, so the NDB is the primary aid, but is less accurate. It works the same as the VOR and TACAN. Now for the EFIS swap. The screens simply swap over, so press it again for the EHSI. There can't be a proper map display with ADF, so press nav map again for the normal presentation. Now to select the localizer. Notice the glide slope scale, and that the to from has disappeared. Turn more than 105 degrees from the selected course, and the glide slope disappears. The Avalon ILS is now tuned, and Ripley is on the ADF. Final course is 177. So, to fly the ILS, we're almost on the finals course and 1 dot below glide slope. Select the expanded scale with the HSI button. That's a much better presentation for flying accurately. There's the Ripley overhead. On the EADI, notice the runway and the glide slope scale. The runway symbol is very sensitive and is useful for identifying trends. Complete the checks and then concentrate on accurate flying. Only small changes are required on finals. Don't over-control. The blue outer marker appears at the bottom left-hand corner. If the ILS has a middle marker, it flashes orange. Don't forget to look up for the landing. That covers the main functions of the EFIS system, how it works, what to do if something goes wrong, and what it looks like operating airborne. Enjoy flying with this great piece of equipment.